Today, we are jumping straight into a massive structural crisis that is currently ripping through Silicon Valley. Right now, we're watching the tech world violently shift from this era of infinite, boundless software hype right into the harsh, physical reality of infrastructure and energy. We've got a lot of ground to cover, from completely vaporized corporate budgets to multi-billion-dollar silicon gambles. So, let's get right into it.
Let's kick things off with a brutal reality check. 120 days. That's it. That is exactly how long it took for the ride-hailing giant Uber to completely vaporize its entire 12-month enterprise AI budget. Just 4 months into 2026, their annual allowance was completely gone. Exhausted. And look, this isn't just some minor accounting error. It proves that unmonitored agentic AI deployment is an absolute financial landmine for corporate CFOs everywhere.
According to verified financial leaks surfaced this week, one Anthropic enterprise customer accidentally burned $500 million in a single month. Yes, you heard that right, $500 million, simply because they didn't have usage caps in place when they migrated to usage-based billing. When you switch from paying a predictable flat-rate subscription to paying for every single token processed, the true cost of enterprise AI becomes horrifyingly transparent. If you're running a startup or an enterprise team, this is the exact math that keeps your CFO up at night.
And a big part of this stems from this obsolete corporate trend known as token maxing. You know, over the last year, companies actually mandated that their employees use AI tools for literally everything, almost treating token consumption as a performance metric. Flat-rate subsidies from tech giants used to mask the true cost of all this usage. But with the rapid shift to usage-based billing, where platforms like GitHub Copilot and Claude Code charge by the token, that massive financial landmine of unmonitored deployment has been completely exposed. Suddenly, the enterprise ROI on AI is under a very harsh microscope.
So to stop the bleeding, companies are slamming on the emergency brakes. Uber is abruptly throttling access, implementing hard monetary caps of $1,500 per employee per month on agentic developer tools like Claude Code and Cursor. Microsoft is even telling its employees to wind down Anthropic's tools and switch back to their internal GitHub Copilot. The wild experimentation phase? It's over. Companies are demanding predictable costs.
When discussing token consumption, we really need to clearly highlight the exponential cost of recursive agent loops. When an employee asks a basic chatbot a question, the token consumption is pretty minimal. But autonomous AI systems, these agentic workflows that continuously loop, test code, and run background scripts, they chew through computing tokens at a terrifying, exponential rate compared to basic prompts. It's essentially like a robot burning a pile of your cache at light speed. Uber actually noted that 25% of their code commits were coming through Claude Code, and their internal agent was writing 1,800 code changes a week. That is a massive, massive token burn rate.
The crucial point here is understanding where the waste actually happens. I want you to contrast the massive financial waste of non-technical workers casually using expensive frontier AI models just to recursively reformat legacy PDFs against the hyper-efficient, hard-coded hard silicon math of a custom processor. It's a fundamental mismatch, right? Software costs are spiraling out of control precisely because users are throwing general-purpose heavy-duty compute at totally mundane tasks. And the ultimate solution to this isn't just slapping on software caps. It's hyper-efficient, hard-coded math on custom silicon.
And the human toll on productivity is very real too. One enterprise developer literally stated, "My job has become solving token usage problems." This operational chaos is so bad, it's even forced consultancies like Accenture to develop defensive software suites called Token IQ to act as a sort of financial breathalyzer, tracking and stopping employees from wastefully burning expensive tokens. Now, this isn't just a Silicon Valley panic. It's a global macroeconomic shift. The World Economic Forum recently released their Top 10 Emerging Technologies of 2026 report, and their conclusion was clear. The technology race has officially moved away from general software apps and directly into physical systems, power grids, and hardware. We're talking about everything to grid energy storage and the massive custom hardware needed to sustain these compute loads. If you're investing or building in this space, take note. If you don't control the physical backbone, you simply cannot survive the token crisis.
As confirmed by Broadcom's formal hardware briefs on June 24th, OpenAI has officially unveiled its first in-house intelligence processor, Jalapeño.
Make no mistake, this is OpenAI's multi-billion-dollar escape hatch from Nvidia's pricing monopoly. It's a massive, reticle-sized ASIC designed specifically and exclusively for modern large language model inference. They aren't relying on generalized GPUs anymore. They're building purpose-driven hardware to drastically lower those power and token costs we were just talking about.
Now, what is truly staggering here is the speed of this development cycle. Typically, custom silicon takes years. But by utilizing their own AI models to accelerate the optimization and design process, OpenAI and Broadcom completed the development of this massive chip, from initial architecture design to manufacturing tape-out, in a shockingly fast 9 months. And engineering samples are already running frontier models like GPT 5.3 Codex Spark in the lab right now. But OpenAI didn't pull this off in a vacuum. Look at this strategic hardware alliance. OpenAI architects the custom chip design, Broadcom implements the silicon and high-performance networking, TSMC physically fabricates the processors, and Celestica integrates the liquid-cooled server racks. This strategic alliance with Broadcom and Celestica presents a massive structural threat to traditional chip design paradigms. It allows OpenAI to bypass the general-purpose graphics card market entirely.
The absolute crucial takeaway from this explainer is how OpenAI is actually deploying these chips. By hard-coding their transformer logic directly into the silicon, OpenAI is securing unparalleled efficiency per watt. And get this, they aren't selling Jalapeño processors to the public. They are building a closed-loop physical fortress, gigawatt-scale private data centers. By controlling the chip design, the manufacturing pipeline, and the server integration, OpenAI is permanently securing its own supply chain and operational costs. They are completely immune to third-party component markups.
Which leaves us with this final, provocative thought. In an era where corporate budgets are being exhausted in just 120 days, and where machine intelligence is mathematically priced down to the micropenny, the companies with the most viral software apps won't necessarily be the winners. As the token apocalypse forces a brutal global reckoning, I want you to ask yourself, who will truly control the underlying physical backbone of our future? Thank you so much for joining me for this explainer. I really hope this helped you map out the reality of the AI supercycle. Keep learning, and I'll see you next time.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.